Okay, welcome back. Welcome. We got three more problems to kind of crank out through here. And again, there's just lots of problems just because it takes a lot of time to get good at this stuff. So you'll see I've already kind of set up just to make it so you guys don't have to watch so much and me copying videos from here or there, vice versa. But I highly encourage you to not watch right now and try 8, 9, and 10. Matter of fact, I'll just be quiet here for a second. Assume that you're going to pause the video and give all these a shot. Go ahead and take the hints down that you're looking at. And even when you pause the video, I think you can probably still see the formulas. Example 8, I'll give you some hints right now. I was going to ask you to use a difference formula. So I'm going to encourage you to try that. And then the next one's going to encourage you to use something if there's a double angle. You don't even need the hint. You're going to try to use a double angle. And the last one, I won't give you any hint on. Just give it a go. It's a little different than something we've tried before, so that one might be tough. But for now, let's just try the first two actually. So 8, 9, pause the video, come on back. Okay, so look at example 8. They're asking to use a difference formula, most important part. Where am I looking? Right, from 0 to 2 pi, I want all the angles that'll satisfy this difference formula to equal to root 3 over 2. Now, I already kind of identified it, but I went back to the formulas. I don't have this stuff memorized either. But notice if I could find something that would cosine, cosine, and sine, sine, and a plus on the middle. Oh, cosine, cosine, sine, sine, and a plus in the middle. I can transform that thing to a something or condense it down, something a little easier to handle. Notice in both cases, and this only works if the angles of the alpha here is the same as that alpha there, and the beta there is the same as the beta there. And I'll erase this in a second. But so those are both alphas, and you can tell that stuff's going on in my backyard, and my neighbors and the dogs, and it's just, I'm just used to it. So at this point, if I'm going to condense, I'm going to take all of this and I'm going to go that way with it. So now I'm going to have cosine of that first angle, which is x, minus the cosine, excuse me, minus the second angle, beta, which is in this case is 2x. And all of that has to just equal this root 3 over 2. If I can shut the window here. I'm sorry. Okay, well, now I have a much easier scenario. So just x minus 2x is just minus x. And remember, cosine x is even. And that's because of this rule. So notice if you ever have a negative on the inside, that's the same thing as a negative, or excuse me, it's just being straight up no negative. So we can actually say this, the cosine of x is just equal to root 2 over 3 over 2. Okay, now remember I'm doing it between 0 and 2 pi. And on my unit circle here, so my circles are getting smaller, I think the answer is pi over 3 to give me root 3 over 2. So please check your chart. But if you're going to write it correctly, again, inverse cosine, and I'm trying to model the correct behavior, even though it's kind of a pain to do at times. So it's pi over 3. Let's do radians this time. However, if you wanted to do all of them, remember you have to go all the way around pi over 3 reference angle. All students take calculus. Cosine's the only thing that's positive in those two quadrants, which means my other x, or my x2, will be 5 pi over 3. Okay, so remember to get both answers that are possible when you rotate around that unit circle. Okay, let's see how you did on the next one. On the next one, I kind of grabbed, there are three options here. If you looked up those formulas yourself, there are three options, but this option here leaves me in a scenario. In the previous video, I was trying to say, hey, sometimes it's just easier if you stay all in cosines or stay all in sines, just because that way you don't have to bounce between two different types of trig functions, and a lot of time the algebra is easier. Now, if that's the case, I'm going to move this over here, or right way over here, so I can utilize this space. minus cosine theta minus 1. That whole thing's going to equal 0. And here we go. It's a quadratic, so I'm going to go ahead and FOIL this thing out, or reverse FOIL it out. And I think if you put a minus, well, let's see, where's that could work? Minus 1 here and a plus 1 there, you'll get something you can work with. Now remember, using the zero product rule, let's see, you can write over here, because I'm going to run out of space. Let's do the first one. 2 cosine theta plus 1 equals 0. Or cosine of theta minus 1 equals 0. Do the easy one first this time. Cosine theta equals 1. In other words, if I take in the 1, what angle will give me that for cosine? And hopefully you're telling me, well, now here's the tricky part. Solve the equation exactly using a double angle formula. It's not saying any other angles it's asking for. So my choices are, because my choices for the range of cosine, remember, are from 0 to pi. Your answer here, if this is a positive 1, should just be 0. 0 radians or 0 degrees. That's right here. Remember, that's the point 1 comma 0 on the unit circle. Let's do the other one. 2 cosine theta equals negative 1. Divide both sides by 2 to get negative 1/2. And here we go. Inverse cosine equals negative 1/2. So my other angle is looking for the angle that's going to give me negative 1/2. And because I'm on a unit circle, I have to go back here. That negative 1/2, let's use a reference angle on your chart. And I think that's probably, oh, I don't know. Let's look. Let's look. And my head's going somewhere else. Just to make sure. Let's say, oh, I can't remember, or you're just not thinking straight. The cosine of what? Pi over 3 gives me 1/2. So I have to correct one other problem, which is why I was pausing there for a second. So that's, again, pi over 3. Sorry, there's some things going on in the background here. I should elaborate, but so that's pi over 3. So for pi over 3, or since we're in degrees, let's just stay in degrees. How about that? Okay. So pi over 3 is going to be, 60 degrees, but because that's 60 degrees, that angle there is 120. You see how I just came up with that? So 120 degrees, boy, this is going to be a good video. I can tell that right now. I'm sorry, I don't know why the computer does this. So as you watch me scroll back down and have this be some unprofessional video, let me write that again. I'm just being patient. I know you guys will learn to be with me too. So I said 120. So that's 120 degrees. Okay. So those are my angles, and pretty much you're done. Now notice you'd have to do more if they wanted all of them, but in this case, you're set. Okay, so there's that answer. Here's this answer. The portion I wanted to correct myself on earlier was up here. The question was, what angle gives me root 3 over 2? And I think I misspoke. So let me go ahead and correct that. And to go ahead, we'll look just to validate everything. Root 3 over 2 should be pi over 6, or 30 degrees. So that's my fault. So if you caught me on that one, good. And if you didn't, shame on you. So this needs to be changed to, and nothing's working now, of course. And you know what? I'm just going to deal with it. Pi over 6, which means also that this has to change to being 11 pi over 6. Because remember, you wanted both the angles. This shit is at pi over 6 here and pi over 6 there. So all the way around would have been 11 pi over 6. Okay, so I'm sorry for that goof up when we had the root 3 over 2 there. That's my fault. But notice the process is the same. If you goof up like that, again, you just saw an example of me making a mistake. I'm human, no big deal. All right, the last one here. This one's going to be a little tough. And the rules change a little bit when, again, I don't know why my computer's doing this. I'm sorry. But the rules change a little bit when you solve for an angle on the inside that has a double angle. So as I scroll down here, and again, I'm trying not to make you dizzy, but this video is taking me for a ride too. End of the day here, I've been making videos all day. And something like this always happens. But normally you would take, and again, notice the most important part, but you're going to take the inverse when you can't do anything else. You take the ratio on the input and then use your inverse notation, and then on the output, you're going to have that equal to 2x. So here's the problem. Problem in this case is that you're going twice as fast. You're now doing, remember when I was showing you normally, and I don't know how this is going to come out because of the difficulty I'm having already, but normally you have, gosh, there's a mark, there's a mark. Tough, my computer, again, as I just complain and complain. Normally that happens in 2 pi, 1 cycle of cosine of x. But as soon as you do or speed it up. The cosine of twice that, that just means 2 cycles now occur in 2 pi. So what happens is, oh gosh, let's see if I can do this for you very quickly. You have a cycle in here and another cycle in here. So now 2 cycles occur in the same time. So if you're really trying to figure out this problem, how often does it happen? And this is how I always look at it, and this is how next section will work too. That you're really, if you're trying to figure out when that thing hits a half, oh, let me just throw that in there. Y equals 1/2. Notice before you only have 2 answers. But when you speed it up, you then have 4 answers. So if you have 4 answers, we got to be careful with that right off the bat so we can kind of compute those precisely and be real careful with what we're doing here. Now, right off the bat, let's get this part right. What angle gives me a half? We already did that one, right? So if I want to know what angle gives me a half, you should be going to your chart and say that's pi over 3. See it? So cosine of pi over 3 equals 1/2. And so that's pi over 3. Oop, and now the pen's not working. Pi over 3 is going to equal 2x. Now on a unit circle, sorry, I'm distracted. This video is just going nuts. On a unit circle, that goes around an entire rotation too, doesn't it? So not only are you going to have pi over 3, but on a unit circle, if I draw it over here, at pi over 3, you're going to have a half, right? Or, excuse me. Yes, one half. And then you're going to have 1 over here. So what you should be saying is, well, Mr. J, you have not only just one rotation at pi over 3, but you're also going to have one at 5 pi over 3 down here. So be careful. You have 2 cases, but when you do this, you're going to have to divide both sides by 2. So if I divide this or multiply by 1/2 and multiply by 1/2, my final answer is going to be x has to equal pi over 6, and x is going to have to be 5 pi over 6. So there's your first 2 angles that you're going to have. But again, that's just really these 2 scenarios. So we got to figure out a way to figure out the other 2. All right, and here's what I would suggest. Because you know that that thing goes, that your first answer was, and I'm going to write this, I don't know how I'm going to write it, in what color, but if you have 2x and your first answer was pi over 3, then you also can consider another full rotation. Same thing for 5 pi over 3. So when you have that, you can also put those together, pi over 3 plus, let's see, 3 over 3, which is 6 pi over 3, or 7 pi over 3 equals 2x. And if you divide both sides in half, or times by 1/2, your final answer over here is going to be 7 pi over 6. So that's a third actual occurrence that you're going to be able to get. Okay? So let's do it for the other one too. So we did that one. But if you rotate around, and again, that'll equal the double angle. If you divide both sides by half, well, actually, before I do that, let's put together that other side. And let's see, 5 pi over 3 plus, 6 pi over 3 again equals 2x. Scroll down a little bit for a little bit more room. And so you're going to get 11 pi over 3 equals 2x. And again, all I'm doing is solving for x. I have 11 pi over 6 equals 2x. Oh, I didn't add that right. I'm sorry. That's not 4 pi. I totally messed that one up. 1 second here. Oh, no, I have it right. I'm sorry. I'm just kind of catching myself here. So that's 11 pi over, not 6, but 11 pi over 3. So yeah, so my answer here, hard to do this stuff when I have distractions in the background, so I apologize, but I'm trying. But this is your final answer. I almost tried to times that by 2 again. So what did I do here? Let's go ahead and summarize. And really, the first two angles shouldn't be too bad. Remember, whenever your original problem, you're speeding up the original cosine graph. Notice that was the red graph I drew right here. And as you have that, all I did is I used the inverse cosine to figure out the first angle, which was x1, and the second angle, x2, just based on a normal rotation around a unit circle, which we looked here. So this was 5 pi over 3, and the other one was pi over 3. So when we did that, to solve for x, you got to multiply both sides by 1/2, there too, and then you end up with these two solutions. For the other two, though, remember we had to consider the fact that we kept going around. So our first answers, if we did another iteration and went around another time, notice plus 2 pi in each case. And really, if this number is a 2, then you're going to have to go around another time. So you have to go around 2 times. If it's a 4, you're going to have to go around 4 times. So just keep going in both cases until you find as many answers that will fit into that domain. So now you have your x3 equaling 7 pi over 6. Notice this is just algebra, put the 2 pi together with this, got 11 pi, and then divided both sides by half to get our final answer down here. And our x4 was 11 pi over 6. Okay, so sorry that was a little chaotic, but that's what things are going to tend to do, even if things aren't distracting in the background. And I got to pat myself on the back on that one. I've had a lawnmower, a dog, my wife in the background, somebody walk in on me, and my computer freeze. So uh, if that doesn't help, get a hold of me in MATLAB. This example here is probably one of the tougher ones we're going to have to do. And again, I'm trying to get you ready for the next section. So practice these extra problems. They're down here. And when you're done, come find me, ask somebody in the MATLAB. They'll help you out. And it's good practice for the next test too. All right, take care.